Proxima Centauri is the nearest star to Earth. Proxima Centauri is a small lunar star in the southern constellation of Centaurus. It is 4.244 light years away from our solar system. Can we get there? Let us look at some figures for the distance. Now, all the figures are in kilometers and kilometers per hour. Lunar orbit. Our moon orbits the Earth at a distance of approximately 384,000 kilometers. July the 16th, 1969. Apollo 11 lifts up from Cape Canaveral, taking Neil Armstrong, Buzz Aldrin and Michael Collins to Earth orbit. From Earth orbit, they take a 384,000 kilometer journey to the moon. They landed on the moon on July the 20th, 1969. After 4 hours in the lunar module, Neil Armstrong became the first man to step on the moon, followed 20 minutes later by Buzz Aldrin. Both men walked on the moon, laid a flag, left some messages and did some experiments. Then the Lunar Ascent module lifted them back into lunar orbit to rendezvous with Michael Collins. Then returned to Earth 2.5 days later and landed July 24th, 1969. This is a scale model of the Earth, the Moon, and the orbit of the Moon around the Earth to scale, done in Excel. Now, the Earth's diameter is 12,742 kilometers. The Moon's diameter is 3,484 kilometers. The model is scaled based on the Moon's diameter. Now, seeing as the Moon's diameter is just more than 1/4 the diameter of the Earth, each square more or less represents one moon diameter. It's not perfect, but it roughly represents the scale of the journey undertaken by Armstrong, Aldrin and Collins. So there are 110 moon diameters between the moon and the Earth, and each square represents a moon diameter. Another interesting comparison is comparing the Sun's diameter, the Earth's diameter, and the lunar orbit's radius. Our Sun has a diameter of 1.392 million kilometers. The Earth has a diameter of 12,742 kilometers. The radius of the Moon's orbit around the Earth is 384,000 kilometers. So the Sun itself is 4 times as wide as the radius of the Moon's orbit around Earth. The Sun is also 109 times as wide as Earth. Apollo 11 needed 2.5 days to cover the distance to the Moon. These are the distances involved. This gives an idea of the scale of planetary distances within our solar system. The Sun is 109 times as wide as the Earth, and this is represented in the diagram on screen. So you will see that there is a long yellow line with a blue dot on its left edge. Now that blue dot represents the Earth's diameter, and consequently the yellow line is how the Sun's diameter would compare with the Earth's diameter. All these diameters are the equatorial zones of both entities. The measuring unit we will be interested in is the astronomical unit. It is a common measure used by astronomers, and it refers to Earth's distance to the Sun. Currently, this is held to be about 150 million kilometers. Now, that is actually about 390 times the distance to the Moon from the Earth. Some more figures that are going to be useful. Looking at the planetary orbits for our solar system, the different planets are as follows. Mercury orbit is 47 million to 70 million kilometers. It has a highly elliptical orbit. Venus has an orbit of approximately 108 million kilometers. The Earth orbits at approximately 150 million kilometers, which is 1 astronomical unit. Mars orbits at 228 million kilometers out from the Sun. Jupiter has an orbit around the Sun of 816,620,000 kilometers. Saturn has an orbit of 1.5 billion kilometers from the Sun. Uranus has an orbit of 3 billion kilometers out from the Sun. Neptune has an orbit of 4.5 billion kilometers from the Sun. This is a scale model of the solar system within the Earth's orbit, so that is 1 astronomical unit out from the Sun. The model starts on the left with the Sun. Now, these distances are only approximate, but the Sun's diameter is 1.392 million kilometers, and this scale model is based on the Sun's diameter. So each square of the Excel sheet we're looking at represents a Sun diameter. Now, Mercury is 34 Sun diameters away from the Sun, which is really quite close. Now, the yellow square at the left-hand side of this scale model is actually the Sun's diameter relative to the distances to each of these planets. Now, clearly, the brown for Mercury, the mauve for Venus, and the blue for Earth do not actually represent the sizes of those planets relative to the Sun. They would be microscopic dots on this scale model if they were shown to scale. However, this is a convenient way of representing how they exist relative to each other and how far they are from the Sun relative to the Sun's actual size. So Earth is actually 107 Sun diameters away from the Sun, which is not as far as you might imagine. This is a solar system depicted in astronomical units. Well, this is not really to scale. However, the P numbers represent astronomical units. The Sun is not 1 astronomical unit, but I use P00 to represent where the Sun is at the center of the solar system. So Mercury, Venus, and Earth exist within 1 astronomical unit from the Sun, that is P01. Then just outside that P01 you have Mars at 228 million kilometers from the Sun, and then at the 5th astronomical unit out from the Sun you have Jupiter, and 10 astronomical units out from the Sun we have Saturn, and 20 astronomical units out from the Sun we have Uranus, and 30 astronomical units out from the Sun we have Neptune. Now, these are immense distances. Now that we have reviewed the distances involved in traversing our solar system, let's look at the interplanetary numbers. We have a light year, and this is the distance traveled by light in 1 year. Now, a light year is 9.5 trillion kilometers. Proxima Centauri, our target, is 4.244 light years away from us. Therefore, Proxima Centauri is 40.3 trillion kilometers away from us. Now, that could be broken down into 268,786 astronomical units. An astronomical unit is the distance between the Earth and our Sun. Proxima Centauri is therefore 104,994,791 times the radius of the Moon's orbit. That is 104 million times the journey that Apollo 11 took to the Moon. To visualize this, let's represent our Sun by 5mm lighted match. Proxima Centauri would be another lighted match or candle flame 144 kilometers away. That would be like having a lighted match in London and looking at another lighted match in Coventry. If you live in the UK, you might know that London to Coventry is about 138 kilometers. If you live in the United States, you could consider that New York to Philadelphia is about 151 kilometers. If you live in France, you'd have a lighted match in Paris and another lighted match in Rouen, which is about 135 kilometers. These are immense distances, and there's no way to represent these figures properly on one computer screen. However, we can do some workings to see how long it might take with a spacecraft moving at maximum conceivable speed using known technology. This is the Parker Solar Probe. It will attain a velocity of 688,000 kilometers per hour as it swings around the Sun. Now, a probe running at 688,000 kilometers an hour would take 6,689 years to get to Proxima. We can't justify that just now, so we'll have to wait for better propulsion systems. To get signals back from Proxima Centauri within 55 years, we would need an average speed to Proxima orbit of say 92 million kilometers per hour. This would require a craft going 133 times faster than the Parker Solar Probe at its maximum, and it would be going at 8% of the speed of light. Amazingly, this would not appear to be possible for the future. You can actually see Alpha Centauri in the night sky in the southern hemisphere. This is a picture of the European Southern Observatory, and it's taken from their website, which they kindly allow us to use. It shows Alpha Centauri, and Alpha Centauri is visible to the naked eye. However, Proxima Centauri is inferred by the locating orange symbol. It's invisible to the naked eye because Proxima is too dim. This is a picture of Proxima Centauri taken by the Hubble telescope. Amazingly, it does appear that you can see the curvature of the Sun, known as Proxima Centauri, and this is 4.244 light years away. Under the magnification of the Hubble, it looks so close. Thanks for watching.